Hi, this is Ajay, TA for this NLD course 2023. Uh, in this video, I'm sharing the solution of this midsem paper. So the first question was, so for a dimensional dynamical system, if we have the trace and determinant of a Jacobian matrix J, under what condition can we get nonlinear centers in a dynamical system? Briefly explain why such centers are not considered to be structurally stable. Give any one example of a system that displays center by writing its equation of motion. So let's consider a two-dimensional nonlinear system. That J represents the Jacobian matrix obtained after linearizing the given system at fixed point x star y star. So our this tau and delta represents the trace and determinant. So for centers, the condition we can see from classification diagram. So this is our classification diagram. So centers lie over this axis. So we can clearly say that for centers, tau should be 0 and this delta should be greater than 0. So condition should be this. So if you got this right, I gave 2 marks for this. The second part was why centers are structurally not stable. So actually centers are the broadline cases, comes under the borderline cases. So any small perturbation on considering higher order terms may lead to the condition for this spiral, unstable or stable spiral. So any perturbation due to the on considering higher order terms may lead to the unstable or stable spiral. So nonlinear centers are not considered to be structurally stable. So for more, you can look over this 6.3 section in Strogatz, fixed points and linearization. The third part is to give an example of a system. So many of you have given an example of a linear system, but it should be a nonlinear system example. So the correct is the nonlinear system for a nonlinear system. So I have taken this example, and this is a nonlinear system example. And if you write this in polar coordinates, you will get this. And if you see clearly that if a is greater than 0, then it shows actually a unstable spiral, and for a less than 0 it shows a stable spiral, and for a equal to 0 we have a center. So this I have taken this example from Strogatz book, one of the example. Now the second question was find the fixed point and stability for this system. So for fixed point we should have this x dot equal to 0, and we get x equal to 0 to be a fixed point of the system. And the second part, so this is the first part. So this x star equal to 0 is a fixed point. If you got this right, I gave 1 marks for this. And the second part is of the stability analysis. So for stability analysis, you have to look over the phase portrait. So this x dot will look like an inverted Gaussian function, and this x dot is positive for any x. So the flow line is actually directed towards positive x-axis. So if you got this stability, so this x star is actually is half stable on the left side and unstable on the right side. So on writing this stability, I gave 2 marks, and for phase portrait you should have got this so 1 marks for this showing the curve and 1 marks for showing the flow. So yeah, so making a total of 2.